Welcome everyone, I'm Javed and today I'm going to present about network visualizations and existing tools and API for network visualizations. So this is the outline of today's presentations. First I'll give an application area of network visualizations, then I'll talk about the challenges in network visualizations, and then I'll discuss about the layout algorithms to visualize the network. And then I'll talk about NetVis Nirapana, that is the properties of an ideal network mentioned by Ben Shinderman. Then I'll talk about common interactions to visualize the network, and then I'll give a list of existing tools and their features that I've gone through, and if I have time I'll show you some demo. So this is a map of Roman road networks called Peutinger from the 4th century BC, and here you can see a part of Asia, Africa, and Europe, and the major cities are connected by various road networks. So it is one of the earliest examples of road network visualizations. So one of the application area of network visualizations from the earliest century. And biological network. Biological network is one of the most applied area of network visualizations. And sorry about that. And here, actually, the biological scientist and the biomedical person, they visualize the protein-protein interaction networks, the genomics networks, to find out special patterns. So here you can see the network analysis of pancreatic cancers and coronary pancreatitis protein interactions. And from this quantitative analysis, the scientists figure out that the protein that is responsible for pancreatic cancer is also responsible for coronary pancreatitis. So we have a lot of applications of network visualizations in the biological science. And then of course computer networks. We can visualize the flow of packets, routing path, and the load on a hub. All of these can be visualized using the network visualizations. And of course the social networks here to understand how an individual is influenced by his surroundings, the security in social network, like if you want to know what are the information is exposed to the friends of friends or an unknown persons, it can be visualized using producing a graph of your social network. And there are also applications in other area like Flickr's, LinkedIn. You can visualize your professional network. Network visualizations has also applications in integrated circuit design, like finding the connections between ICs and all those complex structures. Here you have to be careful about the edge crossing, and also you have to minimize them in bundle. So integrated circuit design has also applications of network visualizations. And here, of course, the modern road networks. You can see Los Angeles County network. It's another example of network visualizations. So all of the networks that we have seen so far can be expressed in either nodes or combination of nodes and edges. So network is nothing, just modeling the relations between objects. So these objects can be nodes, and these relations can be this kind of edges, connected by edges. So all the networks can be visualized in combination of vertices and lines. And network visualization problem is closely related to graph theoretical problem. Like actually graph theoretical algorithms from the core of these network visualization problems. And as we look through all the algorithms and layout, most of them come from graph theoretical approach. So why we do network visualization? What are our main objectives? So the first objective is finding useful patterns. So patterns in the network. Like in the biology network, we try to find the patterns like how a cancer cell is affecting the other cells, something like that. And in the social network, we analyze how individuals are influenced by their surroundings. And also in a computer network, we try to figure out the flow of resources. And another important thing is identify the clusters. Clusters is actually combinations of a similar kind of nodes that have the common property. So if some nodes have common property, we can cluster them using various cluster algorithm. So these are the some common objective of network visualizations. And here I like to mention a website, visualcomplexity.com. Here you'll find hundreds of examples of projects of network visualizations, and you can look into the existing visualization that people are doing. I highly recommend you to visit this site if you are interested in network visualizations. And most of the visualizations is pretty impressive. They have colorful display of nodes, connections, and they provide you meaningful clusters, and you can get an overview of the network from these network visualizations projects. But there are some problems, like most of them are suffering from some common problem of visualizations, like although they give you the structure of the nodes and the cluster, but you can't get much information from this. They don't have support good interactions, and there are a lot of problems. I'm going to talk about that in next slides. So these are the common challenges. All of those projects, most of these projects are facing. Like we have overlapping nodes. You can see all the nodes due to the lots of nodes are posted in the same positions. You have edge crossing. You can follow a path from this node to this node. It will be a mess, like lot of edge crossing. And we also have a common problem. That's actually common problem of information visualizations problem, like scalability. As the number of nodes increases, most of the layout algorithm that layout this kind of network can't fit well, because you have lot of nodes are fitting into the same positions, and you can't lay them out. So it is one of the common problem. And most of these visualization projects don't support going back to previous view. Suppose you are interacting with this node, you are filtered some node, and you should choose this particular layout, and then you go back to another view, but you can't come back to the previous view. That's not supported in most of these projects. And another problem is interactions. Most of the network visualization project I've seen on that website actually static. You'll provide the data, and they'll generate the visualization for you, and you can print it, visualize it, but not much interactions. So to represent this kind of networks, they use different kinds of layout algorithms, and most of them are kind of divided into two areas, like node linking diagrams and matrix based. And this layout algorithm is basically based on the position of the nodes, like how you position the node. And the most popular of this layout algorithm is called the force directed layout. Here actually in the force directed layout, every node is considered as a charge particle, and the edge between them is considered as a spring. So it is actually works as a Coulomb's law and Hooke's law. So the nodes that are connected, there are attraction force between them, and those nodes that are not connected, they have some detraction force. So they normally try to reach an equilibrium where they have elegant spreading of all the nodes, and the node connected is close together. So they actually provide a lot of spreading. You can see here a lot of nodes, but this algorithm is quite provide you spreading and clustering. Like this similar node is clustering, and you can see nice view like that. I can show you an demo, like video demo, how this algorithm works. Like here you can see all it mess up. Like there are lots of edge crossing and nodes overlap. So if I run a force directed algorithm, what it will do? It will by iteration, it will move the particle based on the charge assigned these nodes, and it will try to produce a layout that has no edge crossing or minimal number of edge crossing, and the nodes are spread out. So if I run this video, you can get an idea of this force directed algorithm, how this works. So nodes are spreading as iteration by iterations. And when it will all of them are spread, and the algorithm will come to stabilization. So when all of them are destabilized. And another popular layout, these are the variation of force directed layout. So force directed layout have many variations, and I listed this of the most common force directed algorithms. You can have a look if you have to have it. And different tools support different. No, not all of them are supported, but most common force directed layout is the FR algorithm.
So what's the difference between all of these? Is it purely computational complexity, or
there is computational complexity, and there are also some differences like simulated annealing. It actually works like some threshold. You provide some threshold, it works better than you change the threshold. So there are variations. All of them are same, but there are some variation in parameters like this following spring embedded algorithm like Hooke's law, like spring connections and charge particle, and there are differences.
So when I give the same graph to the different algorithms, the layout that they are producing will be different or not?
Yeah, that will be different, but they work on the same basic principle like force-based.
Okay, and can you somehow qualify where the differences lie? So one is minimizing the number of overlaps, and the other is minimizing the distances between nodes or something like that?
Yeah, the basic goal of all the force direct network is to minimize the edge crossing and spread the node as much as possible. But some of them are not so much efficient. Like this is the first one produced, and it has a lot of inefficiency in terms of scalability. If the number of nodes increases, it's not so good. But this one also with 1,000 nodes, and this one also with 100,000 nodes. Like
okay, so they all minimize the number of edge overlaps.
Yeah.
But the question is how fast they do it.
Yeah, how fast.
And they sometimes do it faster because they place the nodes differently.
Yeah. Okay. Another popular diagram is geographical map. Like here, the nodes are static. Like nodes are placed on the geographical map, and the edges are connected by them. So here you can see a telephone network of US, like from Florida to other. So now I want to talk about what should be the ideal property of a ideal network visualization software. Like these are the properties given by Ben Shinderman from the University of Maryland, and he is very famous for his mantra. He always gives some good mantra to visualizations. So these are his mantra for NetVis Nirvana. The first mantra he gives is every node should be visible in a network visualizations. The second one is for every node you can count its degree. So degree is very important. From the degree you can figure out how interactive this node is to other nodes, and you can follow this degree to get the nodes. The third one is for every link you can follow it from source to destination. It's very important because if you are in case of a transport network you want to find source to destinations. In other kind of social network you may want to find out how this parent is connected to me like this. So following from source to destination is also very important. And the last one he gives like clusters and outliers are identifiable. So if your networks have some kind of common attributes, you can find them in clusters, and if it has outliers, you can figure them out. So these are the four nirvana provided by Ben Shinderman that should be in network visualizations too. And actually he and his research group is working to achieve this NetVis Nirvana, and they basically come up with an idea of semantic substates. Here actually the idea behind the semantic substate is we group the nodes based on their attributes, not like the force directed algorithm. They are going through according to the will, not like that. We'll group the nodes based on their attributes. Here we can see the Supreme Court, circuit codes and district codes cases, and this link means references from the district to circuit or circuit to Supreme. So they place the node based on their attributes, like Supreme Court nodes are placed in top, then circuit and district. It provides mass readability. And according to this, in every region, they arrange the node based on other attributes. So like in Supreme Court region, they attribute the nodes based on the year of the cases, like from 1980 to 2002. So this is the second property. In each region, place nodes according to other attribute. And the third property that I like about it, like give user control of links visibility. So this process like provide user a lot of control. Like user can control which portion I'm interested in. Like here user is interested in only in the 2000 on. So he can just using this dynamic slider. So if he slider, it can automatically update all the content. So he selected 2000 on, and he can see all the connection for this year. So he can filter out this. So this is this makes it much easier for the user and increase the readability of this kind of visualizations, and many more effective than compared to other visualizations in terms of informations. You can get some meaningful information about this visualization and interactions. But it has also some problems, like it's not an ideal solution. Like if your data has lot of regions, 10 or 20 regions, then it will soon take all the spaces in the node, and it will be more complex. And this number of control actually increases exponentially. Like here you have 3 regions, so you have 3 sliders and 9 checkboxes. But if you have 4, it will be exponentially increased. There will be 16 and 4. So this is not a perfect solution. And if your data does not have a certain attribute that you can distribute your node, it will be also a problem, because most of the node, if always 95% of our node is clustered into one data set and 5% is this one, that is not a good solution, because you have a lot of S crossing and things like that. So it works better in certain data set, but not for all kind of data sets. So it has a lot of limitations. So these are the basic interactions I want to talk about, like that is provided by any standard network visualization software. So it provides dynamic filtering by attributes, and when you have a dense node, it provides zooming options to zoom into the nodes, panning options. I'll show you every of this in demo. And we have also dragging, searching, and selecting and scaling options. So these are some basic interactions that are provided by network visualization software. So now I'll talk about the NetVis tools and APIs that I have studied and extracted the features. I have gone through 17 tools, but today I think I'll show 4 or 5 of them to you. The first one I came up with is Cytoscape, and it is an excellent tool and widely used in bioinformatics visualizations. But it has also support for other type of visualization like social network and semantic web. And it is a collaboration between Ford University and also Bioinformatics Institute. So it has almost all the features that I can point out, and it is a complete tool. And it has a good plugin support that you can develop plugin using Cytoscape Open API. And I like this plugin feature very much, because when you do network visualizations, every user has their different need. Like biological scientist has their need. As a social analyst, I have my different needs. So every user has different needs. So if you want to customize the software based on your own need, you can develop the plugin, and there are a lot of plugins available for particular users. So this is a very nice features. Most of the tool has these features, and I like that. And this is implemented in Java. And user interface is also very friendly, like Eclipse-like interface. Excellent documentation and tutorial support, and I'll show you the demo. It supports almost all the major layout, and it combines from different APIs like JGraph and other APIs. It combines them in this tool, and you can find a lot of more other layout in this tool. And it almost supports all the supported interactions, but it's very complete tool, like I'll say. I'll show you like. So here is this tools look like actually, and you can import file or create a file of your own. So it supports multiple import, like you can import network from multiple files from Excel or text file, and also from the web services. So I'm going to upload a local file. And you can see this is the network. It's not showing the color. So it is the zooming option. As you zoom through this net, you can see that level. You can also select a portion of the network. So this is the selected network, and you can see the attribute of this node, selected nodes here in this data panel. And here you can see like this overview pane, like which portion of the network you're looking into. You can move through it, and you can focus on the other areas of this node. And there are a lot of other layout supports, like you can use circular layout, all nodes. It's hard to see, but this is the circular network. And if I use like other kind of network, like it has all the support, like hierarchical layout and course-directed layout. So I can go through all of this. And if you play through this tool, you will figure out more features, like you can select a particular portion of the node, like this network, and you can, if you are interested, like you are not interested in other part of the network, you are just interested in this part, you can select this part, and you can actually create new network from the selected nodes. So if you select this, it will create a new network from the selected nodes. So this is very handy. And you can work with these selected nodes. So let's go back to the slides. And the Cytospace API, like it is also very well documented. And if you want to develop plugins or you want to use the layout algorithms, you can use that. But it's implemented in Java, so you have to use it in Java. The second tool that I'm going to talk about is Gephi. And this is also open source network explorations. And it has version for Windows, Macintosh, and Unix. It also has good plugin supports, and implementation language is Java. And the main features that I like about it, actually, it has 3D render engine, so it is very fast, and it provides 3D support, and it also has a good user interface. And the most important part is it has a timeline component to visualize dynamic network. Like if your network is evolved over time, so you can use this timeline component and go through this slider, and the network will change over time. It also has good clustering support, so you can cluster your nodes based on the attributes randomly. And it also give you access to control the layout algorithms by providing various attributes. And it provides this kind of layout like circular layout, force directed, and actually there might be more layout, because always there is plugin options, so users are developing plugin for different layouts. So I can't say that this layout is not supported by this, because there might be plugin also for this. So this is the Gephi toolkit is look like. I'll show you the on interface. So this is the toolkit, Gephi toolkit, and this is more like NetVis. And this is the network I visualized using our international student associations in Facebook. There is an APP for that. And here you can see all the nodes and the clusters. The different colors means different clusters, and the size means the node size, and the text size means how connected this node is. Like here you can see Natalie Glenn is the most she's the administrator of this association, so she's connected to many people. And this color means a different layout. Like here I see. And it also give you the filtering options, like you can filter it by degree. So if you select the degree, so it will color the node, like red means the most degree. And if you like to see can also look into that. It has the option to show you all the nodes sorted by degree. And you can apply filter here, like from the technology, like degree range, and you can just drag filter here, and you can filter out nodes by degree. Like if you want to only interested in this kind of degree, you can apply filter, and there is no node between this degree. So I apply filter, and it will change the layout based on this. So only on within this degree. So it has also many supports for filtering network, and it is very important. Like you can filter your network based on your demand, and you can also change the colors and all the options. Oh, and another thing I forgot to show, like there's a timeline skill, like you can control the timeline over net. So if your network has some timeline component, you can actually slide over this timeline and show the network. This is the unique features of this tool. And this is another demo, like from the Gephi. I visualize my LinkedIn network using this Gephi. Like here you can see the net clustering. These are all of my friends from back in my Bangladesh university, and these are all my friends in University of Calgary, and there's some other nodes. So it provides good clustering supports, and you'll find it in the LinkedIn if you have LinkedIn account. They provide this support. Another API for the C# and WPF is GraphSharp. It is also open source graph layout framework under Microsoft public license, and it provides some basic layout algorithms like forest based and tree, circular, and Sugima, and some basic interactions. But the problem with this, like it has no documentations, and so you have to figure out by going through the code. There are some tutorials, video tutorials, but no documentations. And another problem is there is no release after June 2009. So it does not support many things, like it has no support for Silverlight and also WPF4. So there are a lot of research can be done with this GraphSharp. Like you can extend it for the Silverlight, or you can extend it for WPF4, or you can provide multitask support within this tool. Actually, I've gone through the blog of this developer, and he said that he's very busy, so he does not have any time to work on this tool. So he's inviting people, if anyone is on to continue with this, he's okay with that. So if you are interested, that might be a good research topic. Another tool is NodeXL, that is developed by University of Maryland. This is basically a template for Excel 2007 and 2010. You download the software, install it, and use as a plugin for the Excel. Like this is an Excel-like interface, and you can load your networks using Excel file or any other format, and it will visualize the node here. And it has some basic layout features, and also dynamic filtering option. It's pretty good actually. It's very easy to use because most of the people are familiar with Excel interface, and a lot of publications are coming out based on this visualization toolkit. These are the features. It's also implemented in C# and WPF, and it has some good libraries of layout algorithms. So if you want to use these layout algorithms for your projects, you can just download their open source code and use the layout algorithm for your own projects.
And that has to run inside Excel. So
no, if you just use the layout algorithms, you can build your own customized applications and use the algorithm to generate the layout. But if you want to use only in Excel, you can also do that.
But I can also use it in our own code.
Yeah. And another one is Tulip. It is also open source and implemented in C++. That's why I don't like it. And another one is actually actually I don't have much expertise on C++. It's painful to code. So it has some good features, like if you try to open, like the feature I like about this tool is and this multiple cascade view, like it has provided you 3 views, 3 or 4 views in a multiple connected way. Like, and you can see a parallel coordinated view, there is this spring embedded view, and there's matrix representations. So this is the feature I like it, because if you select some node here, using this tool, like if I select this node, it will be also highlighted in this tool. So this multiple coordinated view is very useful because it does not bind you to a particular layout, because you may be influenced by a particular layout and your understanding may be wrong. So, but when you compare it with other layout at the same time, you may find some interesting features that might not be possible by just looking into one layout. But it has also some problem, like you're asking some skin space. If you're a larger network, you have to go part by part. So if your data has some multivariate property, this feature is very good. And this always crashes. So it also has a good plugin support, like lot of layout and interactions are available by the plugin, and it's increasing day by day. So it might be a potential good tool in futures. And another one is project. It is one of the earlier tool, one of the most earlier tool for network visualizations. And it's very difficult to use. If you have good knowledge of network visualization, you can use it. But the user interface totally, what I can say, it is not so good. You need time to get used to the user interface, and it does not have any clustering support and no filtering support, because you can't do filtering in this. It is mainly useful for generating a network and print it out. You can't do any filtering, but it has some good layout algorithms. And this project is closed, I think, after 2007, so it is not continuing. Another one is Perfuse Visualization Toolkit. It is developed by Jeffrey here from Stanford University. And he has developed a bunch of tools for this his toolkit, and you can use this toolkit to build any visualization software. Like lots of visualization software is built on this tool, and there are a lot of publications. And it has also web-based support. Like it has a version called Flare. So Perfuse Flash Toolkit that provides animation tools for ActionScript and Adobe Flash Flare. So if you want to develop some visualization for web, you can use this Perfuse Flare Toolkit. And this is the navigator, another software package. It has support 2D and 3D, and it has also implemented based on OpenGL. So it has it's somewhat faster if you have some 3D graphics or more graphics. But it's still under development. So I try to categorize it, but it's not completed, like based on the web-based tools. So I like to talk about the research directions in these network visualizations that is going on. There are 3 areas. Like first one is generic problem that I have talked, like how to active NetVis, Nedavana, and visualizing the multiple layout. So in this domain, you actually have to come up with a new layout, new visualization algorithms, or a new way to visualize a network. So this is the most generic problem, and it's actually difficult, not so easy, because you have to sometimes you may even need to come with different algorithms to visualize your network. Another area is like usability study of this API. Like it can be from 2 perspectives, from developer's point of view and user's point of view. So when you conduct usability study in the developers, you can say what are the features or functions developers like to see in a network visualization API. And it can be also done from the user points of view, like what are the features users like, and what is the most beneficial interactions or point user like to see in their visualizations. But it is very diverse because different user has different needs, like biological user, biological network, social network, so they have different needs. So if you want to focus on a particular group of users, that can be good, but based on the users, this will be very wide. Another area you can work on, like tool or API support. So I've shown you the semantic substrate that is proposed by University of Maryland, but most of the tool does not incorporate this semantic substrate layout, and it has some limitations. So if you want to work on further research on these projects, remove these limitations and incorporate this state in other toolkits, it can be done. And currently, in my knowledge, I did not find any API that provide direct tasks to these devices, but it can be done using the existing layout. We can build on top of them to provide task support for multitask devices. So it can be also done for the development. So these are the 3 areas that I found, but there might be many more areas. And now I'll take questions from you.